As with any delivery of a presentation to a group of people, executives, middle level managers, it's always important to understand the audience. It's important to understand whether your audience is more willing to accept visual cues or, say, analytical cues or even abstract cues. Because the whole purpose is to convey some set of information to this group in order for them to make a decision. So we have a couple of different ways that we will actually present data. One of them is to use graphs. And graphs are a fantastic way to represent data visually. And we have different types of graphs for different elements of data, from pie charts to box plots to line charts. It all depends on the type of data that we're trying to present. Another method of presenting data are summary descriptives. They allow us to measure some summary information about a particular variable. Things like the overall average of the variable, the mean, the median, the mode, maximum, minimum, and so forth. Another way to look at data is in categorical tables. So we can create a table of rows and columns and look at counts of, say, male and female students and students with red hair and black hair along the rows. So we can categorize them and see the percentage of people that are male with brown hair or female with brown hair or male with blonde hair or female with blonde hair. So it's important to understand that there are different types of data that we'll work with. The first thing we need to understand is that we'll have a data set, and a data set is basically a number of rows and columns. And what they really correspond to are variables and observations. Each one of our columns represents some variable, something that we're measuring. And the rows are our observations. These are the individual collection of data that we had for individual responses or an individual situation. Now, some large data sets are not really in rows and columns, and those are actually unstructured data. So we would see that if we were dealing with very large data sets, such as audio or video. A variable, therefore, represents an attribute or a characteristic that's being observed. So we're going to collect, say, the height or the weight of all of our respondents. And these are the columns in the data set. An observation represents a collection of variables for a given respondent. Let's say we're collecting a survey, we have 10 questions. The respondent corresponds to an observation. Now, our data can actually take a number of forms. We're going to have two different categories of data. They can be categorical and it can be continuous. Continuous data refers to numerical information, such as, let's say, a height or a weight, such that all the numbers between any two numbers actually have meaning. So, for example, if we have a height of 67 inches and another person 68 inches, the actual numbers of 67.5 or 67.25 or 67.333, they all actually have meaning and they are usable. In the case of categorical data, that's not so, because we'll just have two levels for a category, let's say male or female, or old or young, or we may have three levels of a category, high, medium, and low. So these different values of a categorical variable are known as levels, and there really isn't any meaning between them. So if you had a 0 for male and 1 for female, 0.5 doesn't really mean anything. Now, categorical data can be broken down into a few different groups. We can have what's called discrete data, which is countable. It's the number of students in a class. Binary data, which is data, categorical data, that only has two possible values, 0, 1, male, female, high, and low. We can have nominal data, and this is categorical data where the order doesn't matter so much. And ordinal data where the order matters, such as ranks. Now, when we have a set of data, it's important to understand what the data represents. So we may collect some data as a survey, and the purpose is to understand something about a larger set of data that we couldn't collect because it's not feasible to collect all of the information. So, what we're referring to is the population and sample. And the population basically refers to the entire group for our analysis. It is basically the group of people that we are inferring from, let's say, a sample, which is a subset of the population of which we've collected data for the purposes of analysis. So, the sample refers to the subset of the population for use in analysis to infer something regarding something about an entire population. What constitutes a population? The population could be anything. It could be all motorcycle owners, all voters, or the entire population of a country such as the United States.